So previously we stopped at example number 7. Today we learn something new. Learn something new. It's called projectile. Projectile is a prediction of location, acceleration, velocity at a certain time. Means you launch one object from one position to another position. You predict the time, velocity, acceleration at all these points. Just remind yourself that every time you start to solve dynamic question, always start with your coordinate system. Where is your x? Where is your y? And so on. Where is your z? And so on. Okay? Where is positive? Where is negative? So, how we analyze a projectile profile or projectile question? We normally start with the axis, y and x-axis, right? And then we start with the initial position. Let's say this red dot on the screen here. Then on the Cartesian plane, you know that you can mark the location x sub 0, y sub 0 is a initial position. Okay, then this object, we have an initial velocity v sub 0. Okay, let's say it move in this direction. Again, all the parameter you use, position, displacement, velocity, acceleration, they are all vector. Okay, vector have magnitude and direction. So we have a v sub naught initial velocity. We can split the vector into x direction and y direction, as you see on the screen. So you should know how to split this one to v x direction, v y direction by using trigonometry, sin, cos, and sine, tangent, cos, and sine. Okay, so it should be no problem for you. So let's say this red dot, we are still at particle dimension. So you make a projectile, as you see on the screen here, you make a projectile halfway. Okay. So let's say this particle move a certain way, and then you stop there. And at that particular time, in this case, we ignore air resistance in this case first. As you move forward, you need to consider air resistance. But for illustration, or for example, for today, we ignore air resistance. So when you ignore air resistance, the only force that pulling the object or particles is gravitational force. Gravitational force acting on a mass. So when you combine the effect, we call it weight, W. And in this case, our gravitational force on the Earth is constant. Although it's not constant, if you move from one location to another location, if you want to be very exact in the quantum physics, the gravitational force will be different. But for general case, we will use constant downward acceleration 9.81 for in our calculation. So downwards, we use negative 9.81 because we assume all the positive direction going up is positive. So going down is negative. Okay. So in this case, you have the second vector v, which is a second location, labeled as v. So again, second location v, every time you have a vector, you can split into x direction and y direction. You should know how to split. This one cannot be like this. Should be like this. Should split like this. Okay. All right. Then you will have your location number 2 x and location number 2 y. Okay. Understand this one? Okay. Now, what happens if you drop a hammer and feather in vacuum? This one is a fun fact. They did an experiment on the surface of moon. What do you think? Which one will hit the floor first? Hammer or feather? Both. Okay, let's watch this one. This is hammer, this is feather. Okay, so both objects reach at the same time on the moon in a vacuum form. Right. So this video also also meet this statement. Air resistance is ignored in the calculation. So recall the three equations that I mentioned before we start the class. First, V equal to V naught plus A C T. Second one, S or delta S equal to S minus S0. V naught T plus half ACT square. The third one, V square equal to V naught square plus AC S minus S0. These three equation is important. Why? In this case, your acceleration is constant. That's why you can use this equation. Okay. So every time we solve a projectile question, we always break our working into either on the top section of our paper or left or right. Every time we solve this projectile question, normally my working is on the left or right. So this one I will do horizontal and vertical. I will solve my all the force or vertical, all the force or all the position or all the velocity, acceleration. I only focus on one direction first. I work on, I solve vertical or horizontal, one side, then only I combine the answer. So I show you how to do. So in this example, I start with horizontal direction only. So I focus on X direction. And then I close all the vertical direction. So to do this one, make sure you convert all the resultant vector, either is acceleration, velocity, into X and Y axis, right? So in this case, all the X to the right is positive. In this case, your acceleration is 0. Why AX is 0? Constant acceleration, what is the direction of the vector? What is the acceleration vector? 9.81. Negative, why negative? Why negative? Going down. 90 degree, right? What is your, this is AY. What is your AX? Zero. There is no acceleration in X direction. So for X direction, you look at the equation. AX 0. So you only reach V equal to V naught. So for your X direction, first parameter is Vx equal to initial velocity in X direction. Make sense? Okay. second equation. You have your AC. What is the value for AC in x direction? 0. This one cancel. You'll get your position. You rearrange this one. You'll get x equal to x naught plus vxt. Need to use this is the, you need to rearrange this equation, change this one to x direction. Okay, so change this one to Cartesian coordinate, x minus x0. Okay, same with the third one, AC 0 in x direction. So your v was same as your initial. It agree with the first one. Okay, this one same with this one. Okay. Look at vertical. Vertical go up positive. What is the acceleration? Minus 9.81. Positive value, minus 8.2 or minus g. So the first equation, how it become into projectile equation, it will become replace AC with the g. You will get Vy equal to V initial y minus GT. Make sense? You only focus on y direction. Second equation, same, replace AC with g. You get y, again, change the s into y, into coordinate system. Okay, y equal to y naught plus y sub naught y t minus g t squared. Okay, same with the third one, replace AC with g, but common mistake, you will forget that g is negative. Okay, so avoid these mistakes. Change this one AC to minus g. Change the velocity in the y direction. S change to Cartesian plane y. It's not x. It depends on your principal axis. For projectile question, normally we set go up positive. Okay. Any question on these slides? No, Okay. So let's look at example tutorial number 8 with the same as your tutorial question. Tutorial question number 34. So let's say you're given a set slice of the ramp here with the horizontal velocity 12 meter per second. You're given the original axis y and x at the bottom of the slide there. If the height of the ramp is 6 meters from the floor, determine the time it needs for the slide to strike the floor and range R where the slide began to power. So you're given a slide from here with with horizontal velocity of this one, and it gives you the height from the floor, 6 meters. You need to find the time need the sack to fall onto the floor. So you need to find also the range where the sack began to pile up, which is the distance where this one will pile up. So in this case, this sack will fall like this. It will not fall like this. In your test or final exam, you need to have a simple logic in your analysis. We won't draw this line for you. You need to predict the motion in the logical terms. If you draw like this, then wrong already. Okay, so normal, it will fall like this. You have a vertical direction. So first thing is to identify your original axis, or like this. Then use 9.81 for your acceleration. Your acceleration is go down, right? So it's a negative value in your calculation. Go down. This is the R that you need to find, where you need to, the location of the set for length. This is the R. So we label the 3 points, A, B, and C. We need to find the time needed to reach from here to here. You have 3 equations. You have 3 equations, V, S, and V squared. Again, the step is split your answer sheet into half. Left-hand side, you do the vertical, horizontal or vertical, never mind. You start with horizontal, then you solve for vertical. Means you split all the forces into y-axis and x-axis. How do we do? First, you split into horizontal motion and vertical motion. So in your solution for test 1, test 2, and final exam, you need to derive the equation. You need to derive equation so that it reach Vx equal to V naught x. You need to write this equation, substitute the substitute the acceleration in x direction equals 0, where you reach Vx equal to V naught x. Okay, so second equation, position, you reach x equal to x naught plus V naught t. And the third one, same as the previous one. This one you need to derive in your solution. So for the first one, Vx equal to V naught x. What is the magnitude? 12 in x direction. So your Vx at point A are labeled as V sub ax, which is the velocity at A position is 12 meter per second to the right. Make sense? Then you go to second equation. Second equation give you position. What is the position here and here? Here you mark as x equal what? 0. What is the x here? Is your R or BC or CB. Okay. Then you have your Vx, right? Vox. What is this? 12, and you need to find the time. So you substitute this R, okay, R equal to XA, initial position in X, and VAX, T. So you have this equation. You can replace R with BC, also can. Okay. When you solve question, remember to explain the notation that you use, right? Parameter that you use. So you replace, you will get this one. Then you solve for vertical. Again, vertical also you need to derive the equation by substituting the location and also the acceleration. So the first one you get Vy equal to V naught y minus GT, y minus, because going down. Second one also same, but you change now x become y. Okay. Then the same for the velocity Vy2. Okay. So the first one, you can start either one. In this example, I start with the second equation. I replace, this is the initial B, correct. This one is the final position at B. So YB equal to the first position at A. So YA plus this one is the initial at Y. What is the initial at Y? What is the velocity AY? Huh? This is the vector, right? This is x direction, right? V you know is 12. Vx is 12. Split your resultant to y direction. What is your Vy? 0. You understand why 0? Yeah. You understand why 0? You substitute value. Careless mistakes is on the negative sign. Why negative 6 here? Why negative 6 here? Because here is 0. Go down, negative. Go up, positive. So your YB is negative 6 because it's go down 6 meters. Negative 6, YA initial 0, VA 0, because in Y direction you don't have velocity, plus minus, right, minus 9.81, you have T equation here. Solving for T, you get 1 point something. For this module, you need 2 decimal place, maximum 3 decimal place. Okay, don't forget the unit. Unit is very important. Okay, any questions so far? Yeah, okay, makes sense to you. Then once you have time, substitute T into the previous equation in a horizontal. Means you can either solve left-hand side horizontal or vertical simultaneously. You substitute back, you get your R equal to 13.3 something. Any questions so far? Yeah, no question, we move on. Example number 9. So you have a chipping machine. So chipping is you design to inject wood chips. So if you're not familiar with the machine, then it might be difficult for you. So what does it mean? So this is the mouth of the machine. So this mouth you can tilt the mouth. Either it can spray this way or horizontal or move up. You can tilt this mouth, this output here. Right? So it gives you the initial design to eject with the velocity 7.5. If the tube is oriented 30 degrees from the horizontal, means this head move 30 degrees up. Need to move, read carefully, the question. Sometimes move down or move up. So determine how high the edge the chip will strike the pile if at this instant they land on the pile 6 meters from the tube. So you are given the distance from here to here. You need to find when the distance of pile here, then you need to find the time they land, H. Okay, so you start with giving location first. Always give the axis, the location first. On the diagram, you draw. Of course, when it comes to test, you don't need to draw like the object, you can use a dot or you can use or a shape to represent the object. Okay, you're given a distance between the mouth or machine and the palm, 6 meter. You're given that the machine tilt 30 degree. So you have the distance x and the y direction, all going up positive, go down negative. So from this mouth, go down is negative. From this mouth, go up is positive. Means this blue line on top is positive, go down negative. You mark as 0 or initial position. Then this is the h that you need to find. It will land somewhere here. Okay, you are given mouth is 1.2. This not inside this one. You're given the distance from ground to this mouth is 1.2. You label location, this one as A, 30 degree with velocity 7.5. So you draw a projectile, intersect with A, 30 degree, right? Then you start solving. Once you establish the coordinate system, where is your origin, where is your end location, then you label X, Y, you label the A, B, C, D, the unknown, the known parameter you put inside your diagram. Then you start to split your answer sheet into horizontal and vertical. So in this case, you split this one to X direction, this one to Y direction. Okay, so what is the X direction? What is your Vx? What is your Vy? Vx is what? Nicole, what is the Y? What is your Vy? I'm asking you on trigonometry. Your Vy is what? How to find A? You have C. Want to find A. Huh? Tangent 30 equal to what divided what? Using this diagram, we have A, B, C on the whiteboard. Those listening online, I'm writing something on the whiteboard. What's the definition of tan 30 using this diagram? You're given A, B, and C. So what is that? You're given A, B, and C. So what is the answer for tan 30? A over B. What is sine 30? A. What is cos 30? Use this understanding. What is your Vy? What information you have? You have C. You need to find what? Where's your Vy? Vy is what? So which one you use? You have C. You need to find A. A equal C sine 30. So what is your Vy? Vy equal what? 7.5 cos 30. Sorry, sine 30. Yeah? Nicole, you need to Photoshop your trigonometry. Okay? Nobody fail in my module yet, huh? Okay, so you know the motion, then you split into Vox and Voy. Okay, be consistent in your notation because we are still at chapter 1. As you move further, it's good to practice to have 0 or O as your initial. Because later, the motion will be very complex. The motion will move, stop, move again, stop, move again, stop. So you need to have a very clear notation in your answer. Okay, so I did explain how to get the VO cos something, right? In X direction, V cos 30, you press calculator, you get one answer. Vy also same, you press calculator, VO sine 30, you get one answer. And the direction is important, huh? X is to the right, Y is going up, positive value. You get positive, what does it mean? It means go up. You get positive, it means go to the right. If you suddenly get negative, it means go down or go to the left. Okay, VAX equal to VOX. This one you know. Okay, means at here, okay, means that here you split into, you go down, right? This one you split into X and Y. So same, huh? So this one you should know, you should understand now why suddenly I can write AX at A position equal to VOX. You should understand, huh? Because in X direction, okay. So horizontal motion, vertical motion, recall the equation that we derived, these three. Then you apply. You apply. So for the first, this one you know already. Then you go to the second equation. X, you focus on A. 0 to A. So you substitute X equal to, X is the final location. So X sub A. This is the initial position, XO, plus V not X. And then T from origin to A. T from here to here. Then you substitute. XA, you know the distance given. XA equal to 6, XO 0. V, you know, you calculate already, 6.5. T, you need to find. So only one unknown. You press calculator, you can find time travel from origin O to location A. Okay, again, don't chase after the number, try to understand the steps. The step is fixed already. If you follow the step, you can find the answer. Okay. Then you go to vertical motion. Vertical motion, this set cannot use already. Okay, you need to focus on Y. So Y direction, you have three equation, these three. You need to derive from the these three equation here. Okay, you derive. Just remember, going down is negative, so your acceleration go down. Minus there. So you apply the first one. I go to the second one. Because you want to find the location. Location. So a bit complex. So YA is location Y. VY go down. Right? And then G there. So how you find? So your YA, which is at this location, you take H minus 1.2. This one, this equation is that we assume H is higher than 1.2. We assume H is higher than 1.2. That's why the equation here we take H minus 1.2. But if you take this diagram that you see on the screen, if you take 1.2 minus H also can. But the answer you will get negative. You will get different. This one is because you assume the H is more than the original size. YO origin O is 0. This one VOY initial Y direction you already find. This is the cos 30, V cos 30 just now. You get 3 point something. T you already find. A you know 9.81. T you already find just now. So you substitute, you can find the H. H is 1.483. So H is here, right? Okay. You can also find using this equation, same. Okay, you arrive at the same equation. Okay, any question on the example number 9? Any question? No, you need rest or you can continue? Okay, we continue. 1 hour already. Okay, we continue lah. Okay. Chapter 1 is a very big chapter. Okay. Let's move a bit faster. So again, remind yourself that we have 4 learning outcomes. So in your final, you have 5 questions. L1, L2, L3, 1 question, 1 question, 1 question. 2 questions you pick from here. Okay. Right. Second half of we will look into curvilinear motion on normal and tangent component. Just now is a linear projectile. What happened now? You have a curvilinear motion. You have a curve. So curve, you will have tangent and normal. Okay, curve. When you have a curve, you have tangent, normal. So very easy to remember. This is tangent. This is normal. Normal is pointing inside the circle or curve. Tangent always on the curve, right, 90 degree. Okay, so as you can see on the screen here, there's a particles moving on the path blue line here. and there's a position change from origin to this position S, and there is a velocity pointing to the tangent and also to normal. Okay, so every time when you have a resultant on the resultant velocity, you can split into two components. If it's a Cartesian plane xy, but if your curvature, every time you see a curve question, you straight away use tangent and normal. Don't confuse yourself with x and y. Every time you see a curve, straight away go into normal tangent solution. Okay, so you have ut, un pointing inside, and the origin of all prime means the curve center. Okay, the rest you read, nothing complex here. Notation N for normal, T for tangent. Okay. Okay, the rest you read. Okay. Planar motion. Planar means on the plane here, you have a curve motion on this plane, on this paper. Okay. Direction. If your tangent position positive, it means that the object is moving from the left to right or increasing. Right? Increasing means the u increasing, the velocity increasing. Normal is this normal axis here is differential arc segment ds is mathematics. By using that you learn in the radius, not radius. There's a chapter in your calculus that you need to find the segment on the curve. You use s equal to r theta. So this one you use differential, but you don't go deep into mathematics. So this, we break each of the curve with small segment that I draw on the whiteboard. So you have each curve you have a center, each curve you have a center, each curve have a center. You should understand why this center is at here and not here, because the curve like this, center here, curve like this, center here, curve like this, center here. Okay, so you have a row with the r. ds is the change of distance, it is here, right? Okay, then you know how to draw the normal axis with it perpendicular to time with this one, t and n, so on. This t means 90 degree to the center. Okay. Then we start to introduce you the unit vector tangent, unit vector normal, ut and un for curvature motion, curvilinear motion. Okay. Okay, this one I go very fast. Velocity, you can split. Velocity again is a vector. Vector, you have magnitude and direction. You can write your vector in a form of v, capital V, small v, and ut. V is magnitude, ut is direction. So particle velocity in a curvature form, you need to write in this form. V equal to v ut. Okay, so start today onwards, for curvature motion, when you need to find for velocity, this is the first equation you write. V equal to v ut. Okay. Then, okay, this one, velocity direction. You know how to draw the direction already. Always 90 degree to the center. Okay, so this is just to denote that is tangent ut. It's just like your vector I identity. Okay, magnitude. Okay, magnitude is use differential. Magnitude of velocity, again, use back the definition, differential of your position. Yeah. Then from this chapter onwards, your notation every time there's a dot in front, then you have ds over dt. Okay, every time from this chapter onwards, every time you see p dot, q dot, the dot means differential towards time. Yeah. Then this one, apostrophe means second position. Apostrophe, second position, and so on. Okay. Acceleration, just now velocity, acceleration. Acceleration, earlier I gave you some cheat already. Acceleration always pointing towards the center. So acceleration, how you define? Acceleration equal to dv dt. So dv dt, how you make in a notation form? You write v naught. Okay, how you write v as naught? So as you learn deeper, because more mathematics model you involve, we want to save time, so we make it more simpler. You don't need to write d something already. Straight away use dot. So acceleration equal to v dot. So what does it mean? You differentiate the vector dot products. Just now, what is your v? Equal to v and then ut, right? This is vector. This is magnitude, direction. These two are vector. So when you do differentiation, dv dt, okay, let's say your vector A equal to a b. You differentiate dA dt, go back to appendix B, it will tell you whole A dB dt plus whole B, you differentiate A dt. Some students, they cannot do this in final because they forget dot products. Again, need to recall your dot products. So that's why you see v dot ut plus v u dot t. Okay. Okay. So I will skip all the derivation. So I go. Okay, I think we stop here first. You have class of this? No, so we go a bit more. Okay, so okay, let me. Okay, so u equal to vt. So when you differentiate with time, you need to differentiate this one, differentiate this one. That's why you get this one. Then we are given you one diagram. So you know that if we pick this dot, we stop the time, we have normal direction and tangent direction. All right. So tangent direction, this one, and if there's a change of angle, then from the tangent point, there's a change of this point to this point. Then we label the change as dut. Make sense? So you start with un and ut first, but when there's a change of angle, you know that normal always pointing normal one, always pointing center one. Okay, so when the change of angle, then the vector form is du. This is du. Okay, now you should know how to read vector form, right? Let's say A, B, C. C is a resultant. How you know it's resultant is start from start point pointing to the end point. Is called resultant. How you write vector equation? C equal to A plus B, right? Make sense? Go back here. Go back to this diagram. UT is A. UT is B. Du is A. This one is d theta. D theta is C. So you can find the equation of du equal to something, right? By using this equation, this understanding. Okay, so I move onwards. So in vector form, just now, I draw on the whiteboard. Du equal to this one, this one. No, not d theta. Just now I mentioned d theta is wrong. This one is C. This is B. This is A. So this one equal to this one plus this one. So d theta, sorry, u prime is C equal to d ut plus this one. Make sense to you? Yeah. Now, for simplification, du which lie on the infinite decimal arc of radius ut, which is du, we always take as 1. This one. These small changes, because this is very, very small. So the changes of this vector is very small. So small until we very hard to find. You can assume there's no changes. We mark this one as 1. So du vector 1. Okay. So du has a magnitude of, how to find dt? Du just now. Just now I write something, I draw an arc like this, right? As r, s equal to r theta, right? So how to find the magnitude of du? dt, you find the dut equal to 1 d theta. Because the du, the r here, no, the r we put as 1. Okay. But anyway, these steps we won't test you. You just need to explain why suddenly the equation later will change. Okay. For diploma, you don't need to go through all this, but it's good that I explained to you guys. Okay. Then the direction. The direction is towards the normal. This one. This one is same as normal direction. So we put as un. Okay. So okay. So you combine these two. This is magnitude, this is direction. So du, you can write in vector form. This one. Du equal to magnitude and direction. Magnitude is this one. Direction is this one. Right? Then you substitute this one inside here. Okay, I write this one right here. So when you do time derivation of this one, again dot product. Okay, you have two identity here. Block this one, differentiate this one. Block this one, differentiate this one. Okay. Then you have dot product. Ut dot equal to theta dot, and this one same. Okay. Magnitude and direction also. Okay, so this one is magnitude, this one is direction. Okay. We go back to the original diagram. We know that these small changes of ds will equal to r d theta. R d theta here. You see the small arc here? S equal to ds equal to this one is rho is a radius times a change of theta here. All right. So ds dt you differentiate with time, ds dt, and this one is rho dt. We just create one more new equation by differentiate towards time. We move this one over here. We'll get s dot. This one become s dot. We move this one to left hand side. This one become this one. So we substitute this one inside here. We get ut dot equal to s dot rho dot un. Make sense? Okay. Then you know that this s dot is what? Change of position or velocity. So you can use velocity divided by r times the normal direction. What's the equation for curvilinear motion? You don't need to show the derivation like this one. You need to memorize and then straight away use. For curvilinear motion, it's very easy one. It's only three equation only. Two equation only. Okay, derivation. Just now I show you this one equal to this one. Okay, I show you this one already. Then acceleration. Acceleration, you substitute this one inside here. You substitute this one inside here. That's why you get V2. Make sense? Then it can be A equal to AT UT plus AN. This one. This okay. This slide is important. Every time you solve A, okay, next class, I want you to remember. This one I assume you already know. But next class onwards, ATVN, you should be able to draw this one. Then equation A equal to V naught UT plus V square. Rho is this is your rho, the R, and UN. Memorize this one. Or if you like, this one of course is AT. This one is AN. This one. So to find acceleration at tangent position or tangent direction, you just need to differentiate your velocity with time. Okay, with this equation. Your AN equal to this one. AN equal to velocity square divided by radius. Okay. How to get this one? You still remember? Do you understand why suddenly this one I can write ds v dv? Because v dv is what? Acceleration. So you acceleration, ds you move to here. A equal to v dv ds. You substitute here, then you move ds to another side. Can you see it? Yeah. So you have three equations. You have at ds equal to v dv. This equation is important for collinear motion. This one. You memorize this one for any curvature motion, it will help you to solve. Okay, derivation you can forget, but it's important you get this equation. So when you have this equation, you need to know how to plot the graph. So again, when you have collinear motion, not collinear, curvature motion, you look at this diagram, you always have one point pointing the center, and also you know that you draw from towards the center, it becomes acceleration normal. And then this one is tangent, so you draw a tangent. You know these two are vector, right? When you combine two vector, you get resultant. You know how to find resultant, right? Square this one plus square this one, square root. Still remember finding the vector? Okay. C, A, B, C square equal to A square plus B square. So how you find A square? How to find C, magnitude? Square this one, square root. Okay. So this is how you draw lah on the diagram. Okay, how you know the direction? You always can calculate the angle from tangent or from normal by using trigonometry equation. Because sometimes you're given the A magnitude, you can find AN or AT by using this equation. Okay. Okay. So this is the general view of how you explain your final answer when it comes to curvature motion. So when it's increasing speed, then there is a change of acceleration. So look at the shape of the curve. They always have normal pointing inside the curve. Same with this point, pointing inside the curve. But tangent always 90 degree towards the center. Here also same. So don't draw the wrong one. And then with this normal and tangent, you can find the resultant by square this one, square this one, square root. Okay. So if the acceleration is along the line, in this case, it's along the line, then you don't have normal. Straight line, you don't have normal. Important, this one. Straight line, you only have tangent, don't have normal. Normal when you have a curve. If you don't have curve, then you only have no tangent. This one become linear motion already. Linear motion, use this one, this three. Okay. I think we stop here. Okay. We continue in next lecture.